Hey guys, welcome to episode 3 of the Open Storage project. So, we've been working here um, to create this project. We are implementing the second function today, the fetch data. That in fact, I'm going to change the name of this. It's not save data, but it's going to be save file. Um, so, we are going to be implementing the second function. The first function we already implemented the previous episode. And remember, this project is about allowing the social persona, the social trading bot, and the network node to have a storage provider that of their choice that can be anything in the internet capable of storing files. Okay, so the first use case is going to be used for trading signals, but also later after that for social persona posts, and then for the network node open social graph. Okay, so let's get to coding this. I'm going to change this function name from save data to save file because we realize that we are storing files, to be honest. So this one we're going to call load file, save and load. Okay, so that's what we need. Okay, so for coding this, the load file method, the load file function, I am going to use let's clean this. I am going to use as a reference what I did for the network, the network project. I think that is the HTTP client. Let me see if I can find. Okay, modules, HTTP network client. Okay, so in this guy, I'm using Axios to fetch data from any HTTP server. And that is exactly what I'm going to do here. And by the way, I'm going to fix this because this should be required here as per our standard. And um, so here this is going to become some more Axios. Okay. Also here, and this require, we will move it to the root module. So we were going to add here Axios. And because this is going to be available at any of these root modules, because it's going to be used in the new function of the storage, what we are going to do is just add it here, add it here, add it here, and add it here. Okay, So I can get rid of this, guys. Can get rid of these guys and concentrate on the missing implementation. Okay, so um, I'm going to copy all this. Probably it's not going to be exactly the same stuff, but to load a file that is stored at the GitHub repository, that is what this module is about, GitHub kind of storage, we will need let's see what it would take to load this via HTTP. README raw. So this is an example of what is needed. We're going to put this on a constant URL. Okay, so the storage container has this is the branch, the file name or path and file name. File path. Okay, so the complete path, we will take it from here, add it there. Then I don't think there is any need of a token because anybody can access this information. It's going to be public. We will need the repo and the owner, yes. That comes from the node. Okay. So the owner is what is inside here. Sorry. The repo is what is in here. This is the branch that for now we got to fix it in main. That is the when I created a few episodes ago that repository, GitHub is using this as a default branch. They call it name now instead of master. So we'll use that here. And then comes the complete path that includes the file path, the file name, and the file extension. Complete path. Okay, so the URL is what we are going to fetch. Okay, but the problem is that if this example that we have, we are making a post. Well, I could bet that this would be a get, and that this is going to be like this. So it seems that the data comes here. So resolve res data. Maybe I should check the res status. Yes, good idea. So I leave this there. And if we cannot make it, this is not save data but save file. Load file. Okay. So probably this is it. Okay. Um, okay. So how are we going to test this? That's the good question. We need to test the save file and we need to test the load file. So what I'm going to do is just to create a test script with the same code. I'm going to do it here. Test storage. Okay. So I'm not going to bother with this being at a remote place and load it using the UI and all this stuff. Just going to put it here. And I'm going to do something like this. So let file name equals my file. I'm going to use this inside. Let file path equals my folder. Let file content equals but I will not have the storage container. So that's not good. With the config, and I will not have the token. So probably it's not a good idea to test it in this way. If I want to have all that stuff, I will have to do the wiring. That anyways I have to do. Okay. Forget about this. The storage, discard. Okay, we don't want this. So where's the platform running? In here. Okay. So I have at my profile this, and I have at my bot this that is referencing the other guy. So what I need to do is to send this to the task server. To send what? The task server is already knows my user profile because it loads all the profiles in order to connect to the peer-to-peer network, right? Yes. So my user profile is already known. Let's get to the code of that. So I'm going to commit these changes because then I'm going to enter into more complicated stuff. Load file function implementation. Okay. So I'm looking for the task server and this module. This module loads when it detects that we are going to be using the peer-to-peer network, then it will run through here. Okay, this is the detection mechanism. So it's going to run through here, and here a peer-to-peer network client identity. I understand that we will have my user profile. Let's check that. Peer-to-peer network identity. Yes, we have the user profile. I'm not 100% sure if we are going to have the social user profile or the user profile, which are two different stuff. Mm, I don't have it loaded in my mind what is going on here, but we will figure that out. But at some point, we will have our user profile. Yeah, let's recap a little bit with this. We have the environment file, right? We're going to put the environment file somewhere here, down. Yeah, somewhere here. The environment file tells the task server, the server app, no, the task server Okay, we need to go back to the workspace of trading signals. From there, we are going to recap and see where are we standing here. Okay, so this task is going to be using the identity of task server app 1. And this bot is going to be using the identity of social trading bot 1. Okay? So, when we are going to be connected to the network, several things happen, including including something that is called, let me find it first. Okay, let's read this. We set up the object that we hold our peer-to-peer network client identity, meaning the identity that we will present to the network. Okay, here we initialize this module, but when we run this one, user profiles, is that identity is going to be actually discovered. So user profiles is this module. And what it does is that this module is useful for all apps that need to operate with all users profile load in memory maps. User profile plugins of the governance system. If I the info they carry, we also need to read the blockchain for blah blah blah. Okay, so this module loads all app schema and also it loads the user profiles. Okay, it creates the user social profiles, and it put them on a map somewhere. Initialize it. Okay, so here what this does, I'm going to clarify this. Store in memory the user profiles. Let's say all user profiles. Store in memory all user profiles. By profile ID, by profile handle, by blockchain account, whatever. So all users' social profiles. Because then that would be neat. But also store here the profiles by ID. Okay. So it looks for all the sign-in accounts of each profile. It's going to recover the blockchain account from each one, and it's going to end up creating also an in-memory map of peer-to-peer network nodes and user social profile by blockchain account, also by the blockchain account of the sign-in account. So if we have a sign-in account, we can easily get which is the user social profile. Okay, I get that. But one of the important things here is that we will get which is the node identity that we are using. And here it can be the task server, each of the task servers that we define. So this node is going to be, there is something not really awesome here because I have seen that peer-to-peer network identity here we define user profile, and at this point we are storing a user social profile. So there is an inconsistency there. Before moving forward, I will try to see if we have a problem. I understand this is not clear. I'm trying to clear myself, to clear it in my mind too. Okay. So it seems that this is outdated here. Okay, so in this place at the task server, we have the network identity that is essentially the node, or it includes the node at our user profile that we declare, in this case here, task server app 1, this node. Okay, I'm trying to clarify where we want to get here, because somehow we have to connect this with the GitHub storage. So then we set up the peer-to-peer network, meaning the array of nodes that we are able to connect to. Okay, this is not our problem now. This is where we will process all the events coming from the peer-to-peer network. This is the network interface. Okay, set up the connections to the network peers. This connection will be used to consume signals, means networks. Okay, so here we connect to the peer-to-peer network via WebSockets, and here via HTTP. So probably this has no relationship with the stuff that we are trying to set up here. What is the connection between the application? If I'm running this application, right? The application has no relationship with the storage container. The social bot has. Okay, and I am referencing the social bot here. So here, this is what tells me what social bot this task is connected to. So the signals are going to be sent on the name of this social bot. Okay? So probably we will need a setup function similar to this one, peer-to-peer network setup, that is going to make a construct similar to this one, obviously much simpler. When it detects that it has at the bot, when at the bot level, when it has this node and this node has a reference to a social trading bot, then it should make a setup. So that's a similar question to this. Okay, it should make a setup inside a new task constant where it's going to store, for example, the GitHub storage module. No, not the GitHub storage, because the GitHub storage is loaded automatically. It's a utility module, but it will load a new module that we haven't written yet, that is going to connect or be accessible for the trading signals functionality, to use that module to store the signals. Okay, so that is the missing piece of this puzzle. That is the missing piece of the puzzle. So let's dive right in the code so that things gets clearer. we'll need a new function here, also an async function. Set up open storage. Okay, yeah. So we say that the open storage at the task server level is going to be needed when there is a bot that has a child of this type, social trading bot reference, and a reference parent. Okay, so we're going to put this here, and we're going to await. Not sure if we need to await this, but set up open storage. Okay, if we receive a bot instance with a child social trading bot reference, social trading bot reference with a reference parent, that would mean that we need to we will need open storage. So is the task node has trading bot instance. Let Control Shift F12 task server APB reference, no, bot. Okay, if it has a bot that has this child, okay, if the task node bot is equal undefined, or bot this is equal undefined, or bot this is equal undefined, then don't need to set up anything. Okay, otherwise we're going to create a new task constant where we are going to store a module task constant that we are going to create. We are going to call open storage, that is going to instantiate a module that is going to be this here. Open storage. Sorry. Projects, open storage, modules. And we are going to call this open storage client, because this is going to be a client to what one day would be the open storage app or something like this. Okay, so yeah, so new open storage modules open storage client, and we are going to initialize this. Initialize. Okay. So we will need here the project schema. We will need the project schema. That we find it here. Project schema. We'll put it here. So here in modules, we will take one of these as an example. Task server module. Well, for now it's good here. I'm not sure it's going to stay here, but yeah. So open storage client. Open storage client. Open storage client. The name of the function is going to be this. Oh, wait. Here. And the name of the file is going to be this. Okay. So we have this defined at the project schema. The next thing to do is to create the file. So at open storage, we will need a folder ts, and inside modules like this one, so new folder modules, and then a new file with this name. Okay, and so the name of the function will go here and here, and this for now will have only initialize and finalize with nothing, and we will need this either, or this, or this, or this. Okay, so we got this now, and we got the GitHub storage. The GitHub storage is already an utility, so it's already instantiated. We can just use it, okay? So in this case, we are going to do, I need an example of how to use these open storage utilities. Okay, this module utilities. Okay, this was not a good example. Okay, so this is the syntax I was looking for. Probably I don't need to do all this stuff to get the syntax, but whatever. Um, so on the storage location, we are going to do this. We are going to do save file, and load file. We are an open storage client. So it's logical to believe that this is going to receive a file. But what we want to do, in fact, what we want to do is to, we don't want to receive a file. Um, Let me put this first. SA. This is open storage. Utilities. GitHub storage. And the function is save file. Okay. So what we needed was a module that allow us to put the pieces together, because we have a task referencing one of these bots, right? And this bot has an available storage, and the available storage has a storage container, and these have a reference here, and this guy has the configuration we need, and this guy has as a parent a GitHub storage. Okay. Okay, so we will need at the task server all this sequence of nodes, which means that we will need to add a file here of the lighting path, but not the lighting path for trading sessions, but the lighting path for tasks. Okay, so we need to load here from foundations. We need to load the function library task functions. We need to go inside here and add something that is not there, that is what is related to the project open storage. Okay, so what I'm going to do is I'm going to add at the end, because there is no need to put it upper, but I'm going to start commenting what I am adding, because otherwise this file this string is getting too long. So the open storage nodes needed here follows. Okay, and these nodes must be in a certain order. If the reference from the bot is to a social trading bot, then we will need the next one is available storage. Available storage. Then the next one is storage container reference. Storage container reference. It's very important to know, not to have a typo here. Available storage container reference. This is going to jump to a storage container. Storage container. Storage container. And this needs to bring me both GitHub storage and SuperAlgo storage. That is another type of storage that we will develop. SuperAlgos storage. Okay. And probably nothing else, because we don't really care about this node or getting back to the user profile. So with this information we added here, that means that the task, when the user press run, will crawl at the user interface. The nodes of the task will jump, and it's already jumping and getting the social trading bot, I guess. Social trading bot, yes. There is something bad here because this is duplicated. Social trading bot reference. Then it's missing the social trading bot and the sign-in account. In fact, this shouldn't be mixed with all the other stuff. I will move this down the line, and I will comment that this is part of the social trading. Social trading nodes. Okay. So the social trading nodes brings me to the open storage nodes that are eventually what we are going to need there. Okay. So probably we need also to make sure that these nodes are all available. Otherwise, something is going to fail when I try to make the connection. Okay, but hold on. Okay, so we are at the task, and the task is bringing me to the social trading bot, which is telling me that it has available storage at different places, and each reference is a container. Okay, so the question is, what are we going to do with when we have more than one reference? Are we going to save it at all of them, at one of them, or pick one from the availables and save it there? What if I have more than one and only I can save it at one but not at some of the others? So maybe the best usage of this possibility is to use one of the availables, and whichever we use, Then we use the trading signals. We broadcast which one is the one we used. Okay, maybe we broadcast the node ID of the container so that it has the detailed information, or maybe we broadcast directly the information of which is the storage provider and the information related to that. If we don't provide this online, that means that the receiving of the signal key will need to figure that out. So what will we give them to figure that out? They have, as of now, they have a map of user profiles, but this will force me to have a map of every single node of all user profiles. That's quite a lot just to figure that out. Well, maybe I can create a map of storage containers at the user profiles module. Okay, that is a detail, but we will have to think about this. What time is it? Um, so yeah, it seems that here we are sending the nodes. We don't need this guy. Mm. Okay, so it looks like this guy, Open Storage Client, what this guy should do, we'll write it here. Um, this module receives a file to save, and it knows which are the available storages for the social trading bot currently running. So it will pick one of the available and try to save the file there. If it does not succeed, it will try at the other places, the other available storage until it succeeds. Okay, so it's going to be very resilient. Okay, once the file could be saved, it will return the ID of the storage container where the file is located. Okay, and pretty much that's it, at least on the first version. So by returning this ID, we can have a map of storage containers by ID. So we retrieve that storage container, and we will just need to know which type of container is that. We can probably have access to the parent node. So once we are there, anyone will be able to go to that container, to that storage provider, and fetch the information. Okay, that's pretty much what is going to happen. So at the task server, there is a place that we save the task node here. Okay, so this is the um, this is a reference to the social trading bot. Okay, and the social trading bot has available storage. Okay, so we're going to say this available storage equals this dot available storage, and in fact if we see this, we can add this here so that it doesn't bother to load this stuff if available storage is undefined. Available storage. Okay, so this goes very close to this guy. Okay, so what we're saying is that we are going to loop available storage and save the file. until it succeeds. Okay, that is what we are going to try. Hold on 1 second. So for let e equals 0, e available storage it has available storage it has an array inside this guy. Available storage. Okay, so let storage container reference is equals this guy if reference parent equals undefined. We will just ignore it. Also, if this guy doesn't have a parent node for a very strange reason, but we will also ignore it because we will need the parent node. But if everything is okay, then let store container is going to be equal to this. And we're going to do this call from here with an await save file, and we know that this guy needs all this information. And part of the information comes from here, downstream or upstream. And here we add the storage container that, by the way, is not well written. So this, the save file of this, well, we will have to do the error handling of this more carefully, because anything can go wrong and everything is going to cancel badly. But we almost have it. Um, so essentially, if this succeeds, it will break the loop and we are going to be okay. And pretty much this is how all this should work. So this open storage client is going to be called by the trading signals module that is going to create a file with all the signals instead of sending them one by one as of like today. And yes, so in order to test this, how are we going to test this? Probably because we need, what do we need? Maybe we can test it from here, from task function. No, not here. From the task server directly. We're going to test it from here. So we don't have to run anything exotic. We already know at this level, which is the whole node structure, and we can write some code to test it. And once we have it tested from here, then we will be able to hook it from the trading signals and send via the trading signals an actual file. Okay, so what I'm talking is from here, from the task server. We're going to test it from here. Okay, I think that we are good. We have written the whole code needed without the error handling or and some other details. So we will have one more episode about open storage to polish all this and to get it ready. And after that, we will jump into the trading signals again. And we are going to make version 2 of trading signals pointing to this mechanism, both for injecting the signals in here and for fetching the signals from here. Okay? So yeah. In the next episode also, we will be completing this function and testing this function too, because from the task server we will need to retrieve these files in order to later test two trading bots consuming signals via all this mechanism. Okay, so that's what we have for the next episode. We complete this function and we test it from the task server, and hopefully in the next episode we continue with the process we had at the trading system, at the trading signals. Okay, so well, that's all for now. Thank you for watching. See you next time. Goodbye.